Okay, welcome to Space Code LLM. Today we're going to walk through our Z editor and talk a little bit of how we can save context. And vibe coding has been really a big thing over the past year or so. And something that I found out is that you can burn through a lot of money very fast. So how do you reduce that? And how do you essentially compile text and make the LLM a little bit smarter and make the attention headers and transformers point to exactly what you're wanting to do. So this project is called Space Code. You could call it a AI agent like um, Claude Code or Hermes agent, but this is really more of the goal of this is to reduce context, the amount of text going into any LLM, whether it be Claude or Gemini. In this case, we're going to really focus on Gemini. You could also use this for anything local with Olama. That's really the focus for this. So let's go ahead and jump into it. So opening up the project here, we have a repo here, and it's just a repo called Space Code. In my personal repo right now, it's a private repo, and we have, if you're not familiar with the Z editor, it is a Rust GPU accelerated editor, and what it allows me to do is just use this instead of VS Code or Windsurf. I used Windsurf before. I paid for the Windsurf license. I think it's great. The problem is that you can spend through $200 of your tokens in like a few hours. So how do you continue to vibe as you would like? And then when it breaks, that's kind of the big thing is during vibe coding, the LLM will lose its context and what I like to call it context rot. Um, And really, there's no incentive for any company that hosts these their own models to reduce the amount of context getting sent to them. So what they use is regex very often, which is good for quick and dirty things, but we want to take it a little bit step further. So what I have here open is a project plan.json, and what this is connected to our Z editor. And because and we have different other things in here. So we have our context that gets saved as we talk. This actually automatically gets pruned over time. We have our instructions that we set manually. Um, if you see T, these are tasks that have been completed and they're long-lived tasks. And so think of them as different checkpoints for the space code project. So as you see here in the atomic decomposition, what it does is it makes sure is that any task that we may create with space code doesn't exceed 50 lines, and that way we can ensure that um, tasks are minute, and that way you reduce the amount of context going to it. And here we have T77, where it actually keeps everything dense. Um, there's really no conversational filler. We just keep things architectural, and that's really what we're trying to do. We have our searchable mutations. So if we try to rewrite a thing, we don't want to rewrite entire files. There's an MCP connection here in which you can plug into Z or another agent, and you have a fly line pouch or fly multi-line patch. And then the roadmap just in general is, like I said, the project plan.json, get plan. These are all the instructions that we get to the LLM. Now, what we have is um, the default Z agent, and it works just fine for this demo. You could replace this, but it takes a lot of work. You'd rather give it some hands with some MCP tools, which is what I have. There's about 30 in this project that they range from applying multi-line, single lines. In our case, you can still reduce your context by about 95% just by compressing text. So we're going to go ahead and show what that does. So we're going to go ahead and index our code base. So we have space code running right now. All we can do is just space code. Let's make sure it's running. local. As you can see, we have different, um, we have a bunch of different commands. The main ones we're going to be talking about are session, um, session, Z, status, and then I think those should be the big ones. Everything else is more of a internal thing, maybe testing a little bit. But oh, we have the chat. So we have chat, and essentially it's an architect type chat agent. That's what the prompt is. I mean, I make it to where you can change the prompt yourself. I don't believe in restricting it or making a black box. You also have an index in which we're able to build the semantic memory. It's not just putting the code into a code base, it's generating passports, it's um, creating the hybrid RAG, it does a lot of things. There's a forest and there's a tree part of this where it can find the exact line of code. And then the Z, so this is how we get it to initiate with the Z agent. It basically just creates some files and then it allows the Z agent to see those. So it makes it a little bit more accurate. Since we're not going to show the NCP in here, this is a good way to reduce it. As I said, we use Gemini, so we can do different models. So if we do space code models, tell me what all models are available. These are generally the ones just for Gemini. That's what we do. A few local ones just for fun, but really the one I use is Gemini 3 Flash Preview. I don't think I think Pro is a little overkill for chatting in the agent. Since we're pointing the attention headers to what we want, it should be just fine. So now that we have that, we want to go ahead and index. So we'll go ahead and SC index. Then we'll set the session to space code. Set any session you want, depending on whatever Git project you're in. This project is about 150, sorry, it's about 15,000 lines. Let's actually watch. And so then that'll set our watcher to be active. And what it'll do is it'll look for any files that change as you build with the agent, it's going to change files. And so you need those to be consistently refreshed into your context. That way it doesn't get old or stale. My issues are, you start going a while, your chat becomes desynced with the agent, and then you just have to you spend a lot of tokens just trying to tell the agent what to do correctly. As you see, it asks Gemini for um, a passport, and so we'll show you what that looks like. If we do SC status, and then we go to our session, space code, you'll see a quick status overview of whatever session you active. So as you can see, the space code command center here tells you what you're using. Is it Gemini? What model you're using? The session name, and then the constellations, which is just an L, um, different levels. So we have L0 through L5. So L0 is going to just be discovery. So just mapping the files into our Docker workspace. The Nebula, which indexes everything into a relational graph model in SQLite. We have our architectural passports, which does a -1 index for every single file. So it basically gives a actual summary of what the file is doing. That way the LLM doesn't get confused. It just sees a bunch of code. What do I do with this? Then we have the vector embeddings, which is a way for um, the it's a way to get the vector. Each file has an individual vectorization path, and then that's how they get related. And so you have whatever file, and you have kind of a line that goes to other files. And so it kind of splits out, so it's more of a timeline rather than a single file. And then it tells you if the Z intelligence is live, so is it connected to Z? And then we have our task management. Um, it could run tasks on its own, but we're not going to do that today. We're just going to focus on copying a task from our project plan, running into the Z agent, and then getting the result back. So first part of space code is that if you run chat, it will have full context history, and then we're able to, as you can see, we have our question here. Now we have a chat initialized, and we can ask it whatever we wanted to. Something I wanted to point out about our space node here is there's a small semantic probe that's randomly generated, so it tells you a different file inside the workbench. And it's a good way to see, okay, what is the context of this file and what does it do? So it's a test verify SQLite database. Perfect. I mean, that's exactly what this file does. So there's another thing here. So for our context sandwich, so as we send the context, we want the context to be rich, and so that's what this L3 is really doing. So let's ask it what we want to create a new feature. Specifically, I want to create a lint feature. So we're going to ask it what lints MCP is available currently. I want to give Z a clear picture of a precise picture. So I'll ask what to do there. It'll go for the rag. It'll also go through your context sandwich for each of the files. You can see what files it used via the debugger. So it's going to pull the ZTS, the registry, and something else. So we're going to go ahead and see search for linter tool. That sounds fine. And so this will look at and this is really what we want. So so most linters just kind of look for errors. We want it to be really precise. So when we change things, as soon as we get to the line level, we can really get there. So we want to map it against the feature node. So these are the tasks it gave us that it wants to run. The first one here is to create a quality.ts to ensure code quality. We then have the lint parser utility using ESLint. And then we have the analyze for quality and with alias and implementing those. So this tool will act as the eyes, which will be great. Right now, as I make changes, a lot of the times I have to do a bunch of tests and it just wastes a bunch of tokens. So don't want to do that. So view different files 51.0. As you can see, the architecture build, so it's going to ask us to work on that. So we're pretty much there, right? We have the mutation, we can make the changes, and now we just need into quality. So we'll go ahead and queue these tasks. We can keep asking the questions, but we'll just go ahead and queue them. Now those tasks will be brought into our project plan, and now we can just send those to the Z editor. It's not be perfect. Oh, this is the lazy way. We could employ the MCP server, but we'll go ahead and just, for demo's sake, put that in here. We're not going to tell it what to do. We're just going to put the code in there, make sure we have our model set up right. We're going to use Gemini Flash. It's only 50 cents per million tokens. And as you can see, it's going to go right. And that's going to run for a second, a little bit longer than that, but it's going to do all those tasks and eventually complete them, which we may have to tell it to complete them. That's fine. Um, but while that's running, we have a chat open, so we can still keep asking it things. So we're going to say thoughts on the focusing on your mental to token usage and then using the instant tools. How can we reduce? So we're going to go ahead and get another set of tasks here. As you can see on another side of our how many context we're actually running to this. We are sending essentially zero, but we have our entire code base index. So to talk to this chat about our code index is only costing us 3,000 tokens, 600 chunks, or you know, 2 microcents. It also gives you the security warning whenever you see certain things. There's a read in here somewhere. So yeah, this is pretty much where the issue is. So it doesn't know which tokens to use, and it's just going to focus on whatever, right? So it's pretty rough. Looks like our task completed. Uh, so it kind of recognizes what I was doing. Um, so this seems to be the issue. All right. So we're going to go and run these. As you can see, our token cost went up a little bit, but that's okay. It should reduce here shortly. I'm going to go ahead and queue up this task. Whenever there's no order, it automatically does that. So it has. So we're going to go ahead and continue on. We'll go ahead and look at that. While it's running, we're going to go ahead and look at the status. Let's see status. We're going to do the tree. And we're going to do session space code. And this will tell us what all files are active in the code base and which ones are being updated. So you see the passport at the end, so it just gives you the quick idea of what's going on with each file. So there's a ton of files, but you can see the db.ts is being updated, so it's waiting for its requery for the passport. If we look at this, it batches things a little bit, so saves a little cost there. We're going to also update our instructions. Looks like it archived everything. So tell it to do it again. Also, make sure our stuff stays at 100%. And so we're going to try to be a little bit more precise with our project here. All right, looks like I did it. We have our project's done. This should be fine. This context this automatically gets pruned over time. So as you can see, our token is kind of staying low. We got a task done. So let's go ahead and queue up the next one. Queue. The one thing about using the Z agent with this is you just gotta make sure that you stand at like 250. Let me just create a new chat. It'll have everything still. It is quite nice. So we're gonna go ahead and run the next one, next set of tasks. Just put it in there, extra line, run the project plan. Select leave. Hopefully save the lot. All right, now let's see how we can make sure this runs. See there. See what it does. There's so I'm gonna ask it, how are we gonna test our new features? We got a bunch of new ones. Hopefully it doesn't get confused by all the tests we already have. Um, hmm. Go on that. And then we will look. And so it did everything we wanted it to do. We will test it shortly. Let's make sure our instructions start. Don't see if it's got updated. Let's see, we went to 508. We need to do 510. plan, 510. Keep those up. We'll go ahead and queue them up. Makes a lot of sense. And then we'll go ahead and add that. I'll get that updated right. That is. Take that out. Okay. No. Now it's still going. I think we'll leave it there. Test. So suggest. I'm gonna go ahead and enable the MCP server in a second. Right. This is the next test we do. Go ahead and fill them up. I don't like that. Right till it stop. Plus these guys. Let's go. We'll just see where it's at. Seems fine. I'm going to start the MCP server. You can see it's in here. Good. Anything with a standard MCP server is able to be used. Oh, it's nice. Just wait for this to finish running and we'll probably rebuild. Cool. We'll go to update on binding. All right, it was in templates, but now our main one is done. So now we have linting, which should reduce our testing cost, which is what the issue was before. It wasn't too much worse than the second one, but you can definitely tell that it was using way more than the regular Z agent, using the custom SCP tools. So we're just trying to get that down, and then autonomy is the way to go, but we'll be there. That's good. We'll be able to jump into it. This task for completed. Let's see what feedback it gives us. Okay. And now we will go ahead and add the final list of tests. And we'll go ahead and run these. And then we will probably be done with this session. And this should be fine. This way, as you can see, our testing needs to be a little bit tiered too, because I don't want to just. The problem with this lint is it doesn't catch everything. It catches a lot, but we want to do a smoke test and then eventually a regression test to ensure that everything is done correctly. And as it opens those, we're going to plan which tests we're going to complete with this. So we're going to go ahead and CMCP sessions base code. And then we'll see the MCP server is now running. Cool. We're going to go ahead and check that it's up. I'm going to go ahead and wait a second before we turn it on. Sometimes voice taking its sweet time. All right, do testing. Now we're going to go ahead and just rebuild and close out everything. Cancel out all that. We're going to do run the install scripts. Install. Cool. We'll do build. Load. That's not what we want to see. So let's go ahead and tell it to run our test. Test. So if we had linting, it would be a little bit better. Go ahead and turn on space code. It should turn on. Yep. We have 37 tools. And now we're going to go ahead and try on. Hopefully it doesn't blow up too much. Since we're able to get the specific lines, as you can see, it's going to go ahead and get the specific line fragment. As you can put it like this, and start line in line, and then what the text is for the file fragment. Oh, no, we'll do it if we can't find the file for the db.ts. You see it ran on multi-line patch. problem with testing on your context compiler is that um, you break it and can't use your chat, but that's okay. That agent is a good backup for all of us. In case it does go down, you get your compiler back up. The chat itself doesn't generally break. It will break if the database is broken, obviously. There's a self-healing logic in here, but it's a little more in the testing phases. So your token usage is going up. No, we've done 1,000 lines of code. It's not bad. We really want to keep it down as much as we can. We only had 4 tests fail. Cool. We're going to see what those were. Way more efficient than what it was doing before. I'll go ahead and come back to this here in a second. Completed. Use about 10,000. It's now costing me about a quarter or a little bit less. All right, one more down. Best part is all the testing. This is probably our main issue. I did not have a startup code issue before, so now we do. It's very nice. I don't have to worry about rebuilding every time on my own. Smoke test looks good. Nice. And that was way better. You know, it used a bunch of tokens, but that's we'll live with that. So this has gotten a little bit too big, so we're going to go ahead and archive this. And then we're going to go ahead and we're going to build. We're going to put something install. There we go. Obviously, it's not working out as well as we want it to. We got different layers here. Well, they do go up, so we'll see. We'll see if the chat works. And then testing. Let's change. It doesn't break, which would mean the database is up. Our MCP server is still going. Yeah, we're still good. Not fresh chat. Nothing we need. So I'm really liking the linter, and I think it looks pretty good. Nice. Because now we have some more quality, which will make sure some of our other some other things work. SC status works. Maybe SC status tree. Make sure that works. Nope. Looks like our tests are pretty good for today. So now we push our changes to Git, and we'll go ahead and Git go manually use PR. Do Git status. Perfect. Add. Cool. All right, now. Now we're going to go ahead and go to GitHub. Go to our space code, and we'll see our latest pull. We're going to go ahead and compare and pull. And let's go ahead and write a description. Links added. MCP to provide. So we're going to go ahead and do this. We're just going to go ahead and pull it manually. And that completes our session. So now we have the merged branch. Go to this, and now we just merged it, so we're good to go. So if we always want to look, we can look at our start README. And it goes a little bit more detail about everything, especially about the vectorization. How do we get the context pruning, and then how does the embedding work for Gemini, and then plain act verify, really how we do it, and the SQL server, SQLite server, SQLite localhost files that kind of make everything happen. So that was the space code demo, and really is now we have a product that can now test a little bit better before it runs heavy byte tests, and now now I can keep using my MCP server, which is great. So thank you for watching this, and we'll talk next time.